So to finish this chapter, I just want to sort of slip in really one other really useful function, and that is filter. And it strikes me this would be quite a good example actually. Now what we can do with filter is we can take an RDD and we can transform it by removing any values that we're not interested in. So as an example, let's say we want to remove from this RDD any entry which is just of length 1. So this here, this here, this here, well, they're definitely not words, they're just single characters basically. We want to filter those out of the collection. How do we do that? Well, this is so simple, I won't even bother with a caption. What we're looking for is on our RDD, which we're now calling words, there's a method in there called filter. So filter will iterate around every element in the RDD. Now we know that these elements are now just single words. So given a single word, the contract of filter is if we return true for this word, then it will become part of the new RDD. If we return false for this word, then it will be filtered out of the RDD and it will not be present in the new RDD. So this lambda needs to return true or false depending on whether we want the word in our new RDD. So as a quick test, we could go ahead and just return true. So that's basically do nothing. It means that every single word is going to be part of the new RDD, so leave it in. So it's a bit daft, but it's worth trying it just to see exactly what it does. So we'll call this new RDD the filtered words, and then we'll be sure that we're printing out the filtered words. So that, because we're always returning true for every element, it has no apparent effect. Whereas if we return false for every element, yeah, and the program's terminated with no output. So obviously those two examples were useless, but you could take it from here now. We can now apply any method to this word that's going to return a Boolean. So we could say if the word dot length is greater than 1, then this will return true and it will become part of the new collection. It will become part of the new RDD. If the word length is less than or equal to 1, then it will be filtered out of the RDD. So a simple transformation, and that looks perfect. We've now got rid of those single numbers. So very common thing to do this when you have some raw data coming in and you have a massive RDD that's probably full of lots of junk that you don't need. You would use a filter to get rid of that junk. So in this example, it may well be we only want real words, we don't want these numbers. Well, I'll leave it as an exercise to you to work out how you would do that, but I hope you're comfortable with the idea of using a filter. Once again, just to close this chapter, I'll remind you that you don't have to do all of these separate operations on separate lines, storing the new RDD in a variable each time. We could have done all of this on a single line, and we would have done it as previously by using the lambdas. So once we've done the parallelize, we can go on to call, I'll just cut and paste from here, we could call the flat map, and we can get rid of this line. Then we would call the filter, then we can call the for each, and we're finished with no need for any intermediate variables along the way. Now I have a compile error there because of the semicolon that I left at the end of the previous line. That's compiling a bit cleaner depending on your point of view. Let's see if that works. Yes, the same output as before. So we are, I think, now beginning to exhaust the basics of Spark, and it's time we started thinking about doing some more realistic routines. So far we've just been working with these hard-coded pieces of data. It would be much better, I think, if we could work with a file. So in the next chapter, I'll show you how to read in an input file from disk.